Hi there, my name is Mr. Delovet. I'm your physics teacher. Today we are going to look at current electricity, and the subtopic under this is energy and power. And our focus today is solving problems. Our focus today is solving problems. So if you have not watched the video or gone through lectures on energy and power, it's advisable to do so they can better understand the solving. Thank you. So let's take one problem and see how we digest it. Okay. Let me go to equation. Okay, let's look for the example of this equation. So there are different equations there. Yep. So we have equation like this one. Okay, like number one, like this. Right, okay. Good. Now the question says that convert 2 kilowatt to joule, right? So what did you do? Now you have to understand what's the meaning of convert. Convert means change. You're changing what? 2 kilowatt to what? To joule. Now, there's always a standard. When you watch the videos or you go through the lectures, you understand that 1 kilowatt hour is equal to 3,600,000 joules, the height is. Now take note of how the units are written. This one is small letter K, capital W, and small letter H. They might say capital J, but the units, the symbol here is small letter because when you're writing units in full, they're writing small letters. Now 2 kilowatt hour will equal to what? X. You cross multiply. So you have X times 1 kilowatt hour will be equal to 2 kilowatt hour times 3,600,000 joules, right? So divide both sides by kilowatt hour, kilowatt hour. So this one cancels this, this one cancels this. Here left with X will be equal to 2 times 3, that's 6. You have 7,200,000 joules. So now you see that 1 kilowatt hour is 2 kilowatt hour is equal to 7,200,000 joules. So that's your response. Are you okay? Good. Hope you have it correct. Now, the next question. Let's look at the next question. So now if I look at the next question, which is this number 2. Okay, number 2. Now, number 2 says a motor is connected across a potential difference of 250 volts and a current of 0.4 ampere flows through it. I made a mistake in typing it, so you're supposed to calculate the power in this equation. So you're supposed to calculate power. I don't know, you can pause the video and see whether you can be able to calculate power using this just equation. Okay, I believe you have done that and you have the correct. So let's see what happens. So when you do this, so the main thing is calculate, and calculate means find something. What am I finding? I'm finding power. Power is a physical quantity. What have been given to me? So the first thing you have to identify what has been given. So in this equation, you have been given this, you have been given that, and you have been given this. Right, and what does that stand for? So how do you identify it? Identify using the units. Identify using the units. Now, V stands for voltage and A stands for volt, and V and A stands for ampere. And ampere represents quantity, current, and volt represents quantity, voltage. So you see that my volt will be equal to 250 volt, and my current I, it stands for 0.4 A. And what am I looking for? I'm looking for power. Now, what formula connects power I and V? So power is equal to I times V. Yes, there's a formula. So you do substitution. And how do you do it? Replace all the values, all the quantities now with their values. So I was 0.4 A times V, which is 250 V. So you multiply these two people, what are you going to have? So you're going to have, yes, you're going to have 100 watts. And so that will be your power that the motor has consumed. Right, good. I hope you had it correct. This is beautiful. Now, let's take the next one and see how we go about it. Good. Now, the next one is number 3. Now, in number 3, I've given us a big equation now. The average set of power, 100 watt, is switched on for 5 hours daily. Calculate total energy consumed in 30 days. So they've given us, first they've given us what? This one. They've given us this guy. And they're giving us this guy. And they're asking us to calculate what? This man. And we asking you have to understand what the meaning of this. So calculate means find, right? Find something. How are you finding energy? And we are talking about power. So how do you know that it was power? Because of this guy. How do you know it's time? It's because of this man. Because these are units of time. How do you know that, okay, in 30 days, this is also what? Time. So how do? You go and take the things I've given. P is equal to 100 watt. Time I've given, which is equal to 5 hours. And they're asking you to look for E, which is what? You don't know. So, but E, which is energy, is same as power times what? Time. And power times time, so you have to multiply it. So power times time will be, the power is 100 watt times time, which is 5 hours. So give us what? 500 watt hours. This is for a day. Now they're asking you for 30 days, right? So this power, they just was switching 5 hours for a day. Now, how do you know it was for a day? This man, daily. Now we want to calculate for 30 days. How many power energy was consumed for 30 days? Now for 30 days, so the energy now will be equal to this energy for 1 day times the energy for 30 days. So it will be 500 watt hour times 30. So it gives you 15,000 watt hour. So this is energy consumed by the TV for 30 days. So but when you are doing it, it's always good. When you're under electric energy, it's good to always convert your answer back to kilowatt hour. And in order to convert your answer to kilowatt hour, you have to divide this value by 1000. So E will be equal to 15,000 watt hour divided by 1000 will give you 15 kilowatt hour, because this K represents, this one represents 1000. So 15 kilowatt hour will give you is same as 15,000 watt hour. Great, right? I think it's cheap. I hope you understand that. Great. Okay, I think the last question we have this, I believe, for this section, I think it's the last question, and we'll do very fast. So you know what I've been given already. I think read the question, pause the video, read the question, and see all what things have been given, and try to see you can do it. So you have given the power, which is 2 kilowatt hour, and you're giving the voltage, which is 250 volt, and you're looking for what? Current, which you just know. But the formula is P is equal to V times I. So you have to make VI the subject formula. So what do? You draw a line, and you take this man down here. So this man becomes a lone here. So you have P and V is equal to I. So you have P now, we can write it this other way. Or is same as P and V, right? Which should be equal to 2 k-watt over 250 volt, which is same as K. I say K is same as 1000. So it's same as 2000 watts over 250 volts. So this one cancels this minus 1, and this one will give you 8. So you have 8 amperes will give you the current that flows through the kettle. Great. I think you have all correct. You clap for yourself if you had it all correct. I think, and tap your back for winning this. Great. Good. Okay.